So this video will look at geometry. It's found on the mathematics textbook on page 420. We look at types of angle first. First type of angle is the right angle. It is equal to 90 degrees and it looks like that, represented with a little box. Then the straight angle, angle on a straight line, it adds up to 180. Then there's the acute angle, which is less than 90 and it is greater than 0 but less than 90. Then there's the obtuse angle, which is greater than 90 but less than 180. Then there's a reflex angle that is greater than 180 but less than 360. Then there's the complementary angles. When you have two angles and you add them up and you get 90, those angles are called complementary angles. And this is the important one. Everybody needs to remember this one. It's the supplementary angles. When you add up two angles and you get 180, the angle are supplementary. So then we look at properties of angles. So first one, vertically opposite angles. When two straight lines intersect, and that is how angles are formed. Angles are formed when lines intersect. When two straight lines intersect, the angles that are opposite each other, or we say vertically opposite each other, those angles are equal. So in this case, A will equal to C and B will equal to D. And for this example here, if you have one angle equal 35, then what will be this Z or what will be this X? If you block out this half, you'll see that that will be a straight line, which is a supplementary angle. So X will be 35 minus 180 minus 35, which is 145 degrees. And because Y is vertically opposite to the 35, Y is 35. So that's the whole idea of the property. Then you have the corresponding angle property. First, to identify the corresponding angle property, you must first see these parallel lines. These arrows indicating parallel lines. If there's no arrow indicating parallel lines, it is not corresponding angle. So, if you look again, if you block out the bottom here, you'll see that the top of the corresponding angle is actually vertically opposite angle. So, corresponding angles is two identical vertically opposite angles. So, A is equal to C, which is equal to E, which is equal to G. All those angles will be equal to each other. And B is equal to D, which is equal to F, which is equal to H. Here we have an example where this angle up here is 70. So the angle here, which is C, is vertically opposite to 70. So this one is 70. This is on a straight line. It's supplementary angle. So if here is 70, then here has to be 180 minus 70, which is 110. And this angle here is opposite the 110, so this is 110. So, and the exact thing that's up here is the exact thing that's at the bottom here. This is 70, the X, Y is 110, Z is 70, and W is 110. That's the corresponding angle property. Then we have the alternate angle property, or it's called Z angle, because it looks like a Z. The alternate angle property comes from the corresponding angle property. Look at this example. This is corresponding angle. And let's say A was 120. Then there will be 60, because those straight lines must add up to 180 degrees. Here will be 120, and here will be 60. Same thing at the bottom here, 120, 60, 120, 60. If you look carefully, the angle in here and the angle there is the same. So if here was 60, there had to have been 60 because alternate angles are equal. Then we have the interior angle. Again, if you look at my example at the top here, you'll see the angles inside the 120 and the 60 will add up to 180. So we say interior angle, the angle here 120, here 60. Interior angles are supplementary, which means they add up to 180 degrees. So if you have an angle on this side, let's say here was what, 75, and they ask you to find X. X will be 180 minus the 75, because interior angles are supplementary, it will be 105. Same thing here and there. But you have to first identify the arrows. If the arrows aren't there, it is not interior angles. So those are the major properties. And we have this one, which is important too. Angle at a point will add up to 100, 360. So angle at any point. This point, that point, that point. You can check it with the example at the top two. 120 plus 120 is 240. 240 plus 60 is 300, plus 60 will give you the 360. So here, 1 is 80. So the next side, vertically opposite angles are equal. Over here has to be 80. This is a straight line, so up here has to be 100 to add up to 180. Vertically opposite angle again, there has to be 100. In the case where you're given three angles, if these two angles will add up to 260, then this one has to be 100 to add up to 360. What you do is x plus 120 plus degrees plus 140 degrees is equal to 360. Those three has to add up to 360. So these two, x plus will give you 260 degrees is equal to 360 degrees. When you take over that 260, 360 degrees minus this 260 degrees will leave you x equal into 100 degrees. Simple as that. Then we look at two properties. We look at properties of angle in a triangle. All the angle in a triangle must add up to 180. Then there's a second property. You see, angle in a triangle add up to 180. That are supplementary. Then there's a second property that says the exterior angle of a triangle is equal to the sum of the opposite interior angles. Let's see that. So the interior angles is 80 and 40. These two will add up to 120. So the exterior angle of a triangle is equal to the sum of the opposite interior angle. Also, this is a straight line, and the angle on the straight line must add up to 180. So this is 60 minus 180 will still give you the 120. For now, there's a few examples here. I'm just going to go through a few of them, and I'll let you do the rest. These examples are found in the mathematics textbook, page 429. Okay, so how do we identify these properties? First of all, this has arrows. As long as there's arrows, these indicate parallel lines. As long as a parallel line, there is somewhat of a corresponding angles or alternate angles or interior angles. In this case, if you block out the bottom, you'll see that up there is interior angle. So if this is 115, up here, which is interior angle, must be 180 minus 115, which will give you 65 degrees. The bottom is 130, then the C at the bottom here will be 180 minus the 135, which will give you 45 degrees. Now, next one. The angle at a point, B is here. The angle at the point must add up to 360, so B is equal to, B plus the 115 plus the 135, like I had it on the previous page, will be equal to 360. So when you add these two, you'll get 200 and this will be 40 and 50, 250, which leaves B to be 110. Okay, so in this case, x plus y is equal to 180 because supplementary angles, interior angles are supplementary. Look at this example here. They want you to find the value of x. So how do we find the value of x? We identify the properties first. This is an alternate angle, so here has to be x. This is interior angle, so x plus 5x must add up to 180 degrees. This will give you 6x is equal to 180 degrees. X is equal to 180 degrees divided by 6. X is equal to 30 degrees. So these are some other examples on this side. I'm going to rush through them quickly. You can pause the video before I solve this problem or these problems and try to solve it on your own, and then check to see if your answers are correct. So this question indicates that the entire angle from here to here, as the arrow indicated, is 60 degrees. So this small piece is 25. What is E? If the entire thing is 60 and this small piece is 25, then E must equal to 60 minus that 25 to give you what is left, which is 25. And this is basically observing. You have to observe first to get the properties, to identify the property first, and then try to solve. I'm not going to do this one. You can do that one. This one you can do as well. Well, let me just tell you what you have to do. Vertically opposite angle, that vertically opposite angles are equal. You can identify that here. And this is a tricky one. Many persons that I've given this one to us got it wrong, but you don't have to. So pause it, try to see if you can solve this thing. But let me solve it now. So I'm looking at a triangle here, but what many persons overlook is the parallel signs, the arrows. So what is E up there? E is equal to 35 because corresponding angles are equal. Many persons say 30 or 30 minus 180 or da. Observe everything there is an int. So we go to this one. What is A and what is B? But first of all, what is the property on display there? The property on display there, if you look first, there is the arrow. And if you blot out this bottom here, you'll see it's alternate angle. It's only turned upside down. So if this is alternate angle, this is the inside angle, then A is the inside angle, then A is equal to 45. And again, if you look, this is arrows, this is corresponding angle. If corresponding angle are equal, this angle here corresponds with this angle out here, so B is equal to 70. And that's how it's solved. The one at the bottom here, I'm not going to do that. First, identify the property. And I think you would have identified, paused, and then try to solve. After you pause, and you'll see that this property is alternate angles. So up there has to be what is there, here has to be what is there, and the angle at the point for S. So there are examples like this, or these, 1 and 2, where you cannot clearly see the answers to these questions. So in those cases, what is sensible is that you extend the lines so you can see the property clearly. Because looking at this just like that, I couldn't have seen that property. So we extend the lines, and then we'll see that, hey, this is corresponding angles because of the arrows. So this angle here is also equal to that angle there. So how do I get this angle here? First of all, if I get this angle here, if this is 100, this is a straight line, then here is 80 degrees. And there's two ways you can get this. Many ways beyond two. There's a property, if you look at this triangle carefully at the bottom there, you can probably identify that the exterior angle of a triangle is equal to the sum of the opposite interior angle. So this is 80 plus 30 is 110. So L is equal to 110. Simple as that. Many persons don't see that. The other way is, if these two are in a triangle, as you can see there, and the angle in the triangle must add up to 180, so it will be 80 plus 30, which is 110 minus 180, will give you this to be 70. Okay? If this angle here is 70, and this is a straight line, and over here has to be 110, and because of corresponding angles, that will be 110 to L. Okay, you can solve this one here. I forgot to put in the parallel signs. You guys can solve that and find what P is. This is 65. This one is like that one, but a bit more complex. So I'll extend the lines for you, and then you'll solve it. This is how it is in the textbook. broken up like that with all the extensions of the line, so you probably wouldn't see the property. So I extend those two lines. I'll also have to extend these lines. So you'll see now it's corresponding angles being cut by two transversal. These lines that are cutting the parallel lines are called transversals. So how do we get to B? Well, put in all the lines, put in all the possible angles, put in that angle, you'll get there. Well, this angle up here is equal to the angle at the bottom here. So this here is 110. And if this is a straight line, here has to be, I don't know, 95 out of these two. And you should get 15 here, and then that will be 165. But go ahead and do it. So that is for properties of angles. Let's come over here to circle geometry. And this will be with the circle theorem. And I'm thinking it makes sense to stop this video and make the next one. But let's proceed. Okay, so to understand circle geometry or circle theorem, we must first know the different parts of the circle, because the properties identify the different parts of the circle, the theorems. So parts of a circle. This long line here is called the diameter. This short one here from the center is called the radius. The distance around is called the circumference. Right? And here is called the center. A line that touches the circle but does not go through is called a tangent. A line that touch 2 points on the circumference is called a chord. The area between a chord and the circumference is called a segment. From here to there, a piece of the circumference is called the arc. So let's get into, we know the different parts. Let's get into the theorems. Theorem 2, starting with theorem 2. Theorem 2 says the angle in a semicircle is a right angle. To first identify a semicircle, we must have a diameter. If there's no diameter there, it's not theorem 2. So the angle up here is a 90 degree. Theorem 2 is formed with a diameter and two chords. It doesn't matter how it is tilted, as long as you see the center, the diameter has to go through the center, and two chords, it's theorem 2. Theorem 1. Theorem 1 says the angle at the center of the circle, O, will indicate the center. And I must say that theorem 2, all the other theorems follow after theorem 2. You can prove that all the other theorems is theorem 2. Right? It says the angle at the center is 2 times or twice the angle on the circumference standing on the same arc. This arc, the arc I showed you just now. So the angle at the center here is 2 times the angle up there. So if the angle up here was x, this would be 2x. If here was 220, up there has to be 110. Because 110, 2 times 110 is 220. How is this theorem 2? Look here, this is 180. And up there is 90. So the angle at the center is 2 times the angle up there. And theorem 1 is formed with 2 radii and 2 chords. So the angle here, if here is 60, up there has to be 30. Theorem 3. Theorem 3 looks like pint dart or butterfly wings. It says the angle in the same segment. The segment is the area between a chord and a circumference. So the angle in the same segment are equal, or the angle in the same arc are equal. But you must see these triangles kissing or meeting like this, like a big X. So the angle up here is equal to the angle up there. So if it was 30 here, it would be 30. If there's 100, over there is 100. Theorem 4. Opposite angles in a cyclic quadrilateral are supplementary. We already know supplementary means they add up to 180. So they will add up to 180. So P plus Q, because they're opposite each other, they must add up to 180. What's a cyclic quadrilateral? A quadrilateral is a four-sided figure. A cyclic quadrilateral is a four-sided figure where all four sides are touching the circumference, or four vertex touching the circumference. Here you see theory 2 again. I didn't show you theory 2 for this one, and let me show you theory 2 with that one there. If you have the center there, and you have a line there, and you have one, well, theorem 2 said there is 90. If you have a next one, there is 90 again. So theorem 2 is theorem 3. Theorem 4 is theorem 3 because you have two semicircles and the opposite angles 90 must add up to 180. And you can also have a quadrilateral in a semicircle and the opposite angle must add up to 180. So if this side was 65, this side will be 115 because the opposite angle must add up to 180. If this side is 120, this side has to be 60 because the opposite angle must add up to 180 degrees. Theorem 5. Theorem 5 says that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. The angle out here is equal to the angle opposite in there. We can prove that. If here is 60, up there has to be 20 because theorem 4 says the opposite angles are supplementary. They have to add up to 180. So if here is 60 also, this is a straight line. Out here has to be 120. So the opposite angle outside here must equal to the angle up there. Now we go to tangent, that's theorem 5. Now we go to tangent to a circle. Every time a tangent meets a radius, it forms a 90 degree, and that is theorem 6. The angle between a tangent and a radius is perpendicular or 90 degrees. Theorem 7. Theorem 7 says that from an exterior point, only two tangents can be drawn to the same circle. I can prove that. If you have an exterior point there and you try to draw any other than a two tangent, the other will become a secant. It will go through the circle. Right? So it says tangent from an exterior point to a circle is equal in length. What does that mean? It means if you have one point and you have two tangents coming from that one point, it will equal in length, which forms an isosceles triangle. Isosceles triangle, the property of an isosceles triangle states that two sides are equal and the base angles are equal. So, how do we find this angle here, x and y, or these angles there, x and y? So, x and y are base angles of an isosceles triangle. The angle up here is 80. So to find that, we say, well, let's first find x. X is equal to 180 minus the 80 up there divided by 2, which would be 100 degrees divided by 2, which will give you 50. Why are we subtracting the 80? Because angles in the triangle must add up to 180. So x is 50. Y is 50. If x is 50, y is 50 because base angle in an isosceles triangle are equal. So 80 plus 50 will give you 180. I'm showing you something now. I'm jumping the gun because this is you'll see the theorem just now. But if here is 50, here is 100. Because it's a theorem, it's at the end of the page. Theorem 9 that says the angle of the center here, the angle between a tangent and a chord is half the angle of the center. So if it is 50, there's 100. And you'll see that later on again. Theorem 8 says that the angle between a tangent and a chord is equal to the angle in the alternate segment. Here we're talking about segment again. Segment is the area between a chord and the circumference. So this is a segment. Okay? So this is one segment on this side. The angle between a tangent and a chord in this segment is called x. So the angle in this segment formed with the tangent and the chord is x. It must equal to the angle in the alternate segment. The alternate segment is this other segment. This is one segment, minor. This is the major segment. So the angle up here has to equal to x. Alternate segment. So if this segment, the angle there is y, the angle up here in the other segment must be y. So we have 40 in this small segment, so up here in the big segment has to be 45, sorry. If the angle in this segment is 60, the angle in the other segment is also 60. And then the theorem 9 that I was talking about earlier. Theorem 9 and theorem 1 shares similar qualities. So here we go. The angle between a tangent and a chord is half the angle of the center. If the angle here is x, the angle there is 2x. And look how theorem 9, 8, and 1 fits in perfectly. Theorem 8 says the angle between a tangent and a chord is equal to the angle in the alternate segment that is up there. So if here is 50, up there has to be 50. This is the alternate segment. Theorem 1 says the angle at the center of the circle is twice the angle in the circumference. So here has to be a 100. But theorem 9 also says the angle between a chord and a tangent is half the angle there. So if this is 100, there has to be 50. So that's that's a relationship between theorem 8, 9, and 1. So here are some examples. This example is from the textbook. How do we proceed to solve the circle geometry question that comes in question 10, CXC? This is how we do that. We look and observe before we try to solve the thing. We observe what properties we can identify before we try to solve. What I used to do is to observe and put in all the angles I know, and then I go to solve the question. So here we go. If I look at this, I'm seeing a diameter which forms a semicircle, and which means that theorem 2 is there. Angles in the semicircle, the triangle in the semicircle there has to be 90. So this one is 90. And this is before I attempt to answer this question. At the top there I can see a four-sided figure which is a cyclic quadrilateral. So up here, and it says opposite angle in a cyclic quadrilateral are supplementary. So if here is 72, up there has to be 108. That's before I go to solve this question. I see theorem 5 here. It says the angle outside, exterior angle, is equal to the opposite interior angle. So if there is 136, up here is 136. Do I need anything else? This is angle on a straight line. If the angle on a straight line is 180, if this is 36, then this is 44. And also we can see the opposite angle in a cyclic quadrilateral is a supplementary. So if up here is 136, then the opposite one there is 44. Good. I observed all my theories there and I put in the angle. Now I'm going to solve the questions. For these questions, you have to give reasons for your answer. So every answer has a reason. So first one, ADC. ADC. Where is C? ADC. That is the angle here. We said the angle on a straight line is supplementary. So here is 44. And the theorem is angle on a straight line is supplementary. Please write it out. I'm just going to put straight line. Or please put angle on a straight line is supplementary. Next one. AED. 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 That's always the angle where this vertex is. The one in the center. This is 90. It's equal to 90 degrees. Why? Because of theorem 2. Please write out theorem 2. Angles in a semicircle is a right angle. Then ABC. 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 That's up here. Exterior angle of a cyclic quadrilateral. 136. Theorem 5. Please don't write theorem 5 in the examination room. Okay? Because they wouldn't know which one is theorem 5 or what you consider to be theorem 5. Write it out. Opposite angle in the exterior angle in a cyclic quadrilateral is equal to the opposite interior angle. Final one. BCD. BCD. That is here. And we did that already. Opposite angle in a cyclic quadrilateral is supplementary. This is 180 minus the 72, which will leave you with 108. And the reason is theorem 4. Yes, 4. Okay, so we look at this is from May 2016, last year. How do we solve this? Okay. First, again, we try to identify our theorems and properties. There are a few properties in here. There's always, for circle geometry, theorems and properties for angles. So I see two tangents, which means that is theorem 7. Theorem 7 is there. I see radius connecting with tangent, which means theorem 6 is there. I see a quadrilateral inside, which means possibly theorem 4 is there. Yeah. I see radii is forming triangles, which means isosceles triangles are there. So I see theorem 7, 6, and 4, and properties of isosceles triangle. So now I can proceed to solve. If this is 44 up there, this is an isosceles triangle. So the base angle must be 180 minus the 44 degrees divided by 2. 180 minus 44 is 136 degrees. 136 divided by 2 is what? 68? Yes, 68 degrees. So here is 68 degrees. If there is 68, then up here is 68 degrees because it's the base angle of an isosceles triangle. So, sorry, I'm jumping the gun. I didn't check the question. EHF. E is out here. HF. Oh, good. That's the same question. 68 because, and you have to give reason again, base angle in an isosceles triangle are equal. FGH. 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 This is the angle here. FGH. I wonder if anybody saw that. What is this angle up here? Let me show you. Plot out there, all you have is a triangle. And out here, the angle between a chord and a tangent is equal to the angle in the alternate segment. Up here is 68 as well. 68 degrees because of theorem 8. Then JHE. JHE. Oh, JHE. JHE. This entire angle here, JHE, from the line JH to the line HE. That is a radius. Well, it's a diameter, still a radius. And that is 90 because the angle between tangent and the radius at the point of contact is perpendicular. This is theorem 6. And this is how we solve these things. The last one is JGH. This big angle here. JGH. And again, this is 90. And this is theorem 2 because if you look again, it's a semicircle. And the angle in the semicircle is a right angle. And that's it. For each of these was 2 marks. That's it. 8 marks. Okay, so let's look at 2014. This is the last one we're going to look at, and I am not going to solve it. All I'm going to do is tell you what is there. This is a tangent, so which means theorem 6 is there. Angle between a tangent and a radius, so the radius there. I can see theorem 1, the angle of the center is twice the angle in the circumference. I can see theorem 4, opposite angle in the cyclic quadrilateral are supplementary. I can see an isosceles triangle, definitely. I can see theorem 8, exterior angle out here is equal to the big angle in there, not this small one, the entire thing. So the 4th question is BOE. BOE. This is the big angle here. You guys determine that. If this is 20, over here the small one is 20, and the angle, because base angle in the isosceles triangle are equal. You need to write down all the properties you use to get this one angle. I would have written, first of all, base angles in isosceles triangles are equal. So over here is 20. The angle BEO is 20. And then angle in a triangle must add up to, supplementary, must add up to 180. So up here is 140. And that's it. Then they ask for OED out here. OED, the small one out here. If this one in here is 20 like the other one at the bottom there, then out here has to be 22 because this entire thing is 42 because of theorem 8. So this one is 42 degrees minus 20 degrees, which is 22 degrees, and the reason is theorem 8. Exterior angle is equal to the, but you have to see that first. The last one, BFE. We know out here and out here are opposite angles in a cyclic quadrilateral. So up here, if down there, I think down there was what, 140, then up here has to be 70. So this side must be 110. I don't know. We check it out.